Okay, this is a continuation of damaged DNA video for DNA Lab 2021. I've sort of had started filming right in the middle of loading the Agarose gel, so I was able to form a gel by melting the agarose in the microwave, and you can also heat it up on a hot plate, and then before I pour the gel, I inserted this comb, which left some depressions, which are the places where I'm loading the sample. One of the samples is a DNA marker. It's a ladder of different sized DNA molecules to allow me to calibrate the size of my unknowns. And then here, these are my samples. I'm mixing the loading dye, which adds some color and makes the solution more dense, and now I'm pipetting that solution into the well. So kind of a delicate operation. You want to have steady hands. And with some practice, it's relatively easy. Some of the samples I'm noticing are difficult to pipette, but I'm hopeful that we'll be able to see something on this gel after running the gel. And this is a jargon term, to run the gel. What that means is we'll be passing some electric current through the gel and putting the gel in an electric field. And the DNA is a charged molecule, and it will travel away from the negatively charged anode and towards the positively charged cathode. The color, the blue dye in the loading buffer, is also negatively charged, so I'll know that everything's going in the right direction when I am in the middle of electrophoresis by monitoring how the blue tracking dye travels. Now this gel box looks a little bit different from the ones that we'll be using in DNA Lab, but the concept is the same. We attach the electrodes, and then we program in. I'm going to use 140 volts, and I'll set the milliamps to some safe limit, like 250 milliamps, and then the time, I'm going to try 45 minutes here. And then I hit the run button, and this power supply will count down the 45 minutes and stop when the electrophoresis is finished. And if we look closely, we may see some bubbles emerging at the different terminals of this electrophoresis chambers. There's large bubbles at one end and small bubbles at the other end. I think you're hydrolyzing water into oxygen and hydrogen. And the important thing conceptually is that the DNA, which started out in these wells, experiences electric field, which causes a force for them to move through the molecules to move through the agarose, and large molecules will experience friction and will have a lower mobility, and small molecules will travel faster. It's not only dependent on the size of the molecule's shape, also matters, and if the protein is making a complex with proteins, that could change the mobility. There's a lot of things that will determine the mobility. We don't see the DNA right now, but in the agarose gel, there's a fluorescent dye that will complex with the DNA, and then when you shine long UV light on the gel, that dye will fluoresce more brightly when it's chelated or intercalated between base pairs. So we're going to use fluorescence staining to detect where the DNA is in the gel after this electrophoresis experiment. And the result of that will be a photograph that we'll post separate to this video.